Hi guys, hope everything's going well. I've got another lesson looking at molecules today. Um, so what we've been looking at this topic is called bonding structure, properties and energy. We've been looking at molecules lately. The bonding in molecules is that sort of covalent bonding where they share electrons. The structure we've been looking at, so the different shapes of it. Today we're going to be looking at some properties. So click on slides and it's called molecular properties. So I'm looking at today. So we were looking at polarity before, and one of the properties you need to know is solubility. So solubility is how well something dissolves in a solvent. And a solvent is just a liquid used to dissolve things. So we use the rule like dissolves like. A non-polar molecule will dissolve in a non-polar solvent, and a polar molecule will dissolve in a polar solvent. What you need to know is they're only going to use two different solvents. One is water. Water is definitely polar. Usually you can just say water is polar. You don't need to prove that water is polar. You prove the other molecule that's dissolving in water is polar by looking at its shape. And the non-polar solvent they usually use is called cyclohexane. But if they're using cyclohexane, they'll probably say it's non-polar. So the important thing to remember is like dissolves like. So here I have sodium chloride, which you should know is table salt. And if you put table salt in water, will it dissolve? Yes, it does. You should know. So is salt polar? Well, it's not a molecule. It's an ionic substance because it's made from a metal and a non-metal. But is it polar? Yeah, it's really, really, really polar. It's got a positive sodium and a negative chlorine. So it's very extremely polar. So it will definitely dissolve in water. This is what cyclohexane looks like. As you can see, it's a very symmetrical molecule. And the only thing you really need to know about it is that it's non-polar. Because it's non-polar, the sodium chloride will not dissolve in it. So polarity, like dissolves like. The next property is the melting and boiling point. So first we have to look at the different types of bonding inside a molecule. We have things called intramolecular bonds and intermolecular bonds. Atoms inside the molecule, so here's one molecule here, HCl, and here's another molecule. These two atoms inside the molecule are held together by very strong intramolecular bonds. Intra means like within the molecule. These intramolecular bonds are covalent bonds and they're very strong. Now, between separate molecules, we have weaker attractions. And these attractions are called intermolecular bonds. So think of like international between two countries. This is intermolecular between two different molecules. And so these ones are a lot weaker. These intermolecular bonds are a lot weaker than the intramolecular bonds. So if we want to melt a solid, say we have solid HCl, got to be really cold to make that. If we want to melt it, we have to weaken these intermolecular bonds, so the bonds between separate molecules. And the way you do that, if you want to melt something, is you add heat energy. When you add heat energy to something, it causes these molecules to vibrate faster, And as they move round, the intermolecular attractions will break. How do you do this? Here is what should we go? Water. Water's good. Here is some water at about 146 Kelvin, which is very cold. And you can see it's basically solid. If we heat it up, what's going to happen is the particles are going to start moving faster. As they start moving faster, they're going to start spreading apart soon. Moving faster, spreading apart. You can see some of them have got free, and those intramolecular bonds have started breaking up. So basically, introducing heat to a substance is going to make the particles move faster and break the intermolecular bonds between molecules. Molecules generally have very weak intermolecular bonds, so that means not much energy is needed to break the bonds and melt the molecule. So if it's a substance with a low melting point or a low boiling point, such as, I don't know, oxygen, hydrogen, gas, it's probably going to be a molecule. So molecules, low melting and boiling point. Cool. Electrical conductivity. We looked at electrical conductivity with ions, and basically what I said is a substance can conduct electricity when there are charged particles that are free to move. You asked about the electrical conductivity of a molecule or a molecular substance. You can be certain that it does not conduct electricity. This is because molecules do not have a charge. They've got an overall neutral charge. They don't have a little 2+, or they don't have ions associated with it, or any free to move electrons. So molecular substances are always electrical insulators, do not conduct electricity. All right, well, that's all for the actual, properties of molecular substances. Let's just have a quick look at some of the exam questions. So, sorry, I should have had that ready. Here we go. So this is what you will get often. Here's an exam question. And we have three substances here: sodium, sodium iodide, and iodine. And you have to say the type of solid. Now we've learned two so far: ionic and molecular. So which one's ionic? Ionic is the one which is going to be made from a metal and a non-metal. Sodium iodide, that is ionic. The molecular one is only going to be made from non-metals, or atoms on the right of the periodic table, iodine. And the metallic one is only going to be made from metals, which is the one on the left. But we haven't looked at metals yet. Sodium. So let's have a look at one of these questions for the molecular ones. Here we go. Compare the solubilities of iodine in water, a polar solvent, and in cyclohexane, a non-polar solvent. All right. Using your knowledge of structure and bonding to explain the solubility of iodine in these two solvents. So the first thing is we have to look at iodine, I2, and work out, is it polar or non-polar? I think I2 is going to be non-polar, because the two atoms, iodine, these two iodine atoms, both have the same electrical negativity. So neither one of the iodines is going to attract the electrons more. So this is non-polar. And then I can say, because it's non-polar, it is more likely to dissolve in the cyclohexane. Well, it will be more soluble in the cyclohexane, which is non-polar, and the H2O, which is polar. Let's see what they say. They probably go into a bit more detail. So iodine is a non-polar covalent molecular substances made up of I2 molecules held together by weak intermolecular forces. So they're saying it's molecular, they're saying it's non-polar, and they're saying the forces holding the particles, or the actual iodine molecules together. Weak intermolecular forces. Iodine is soluble in cyclohexane, but does not easily dissolve in water. Now here's the important explanation, which we didn't really look at. But basically the way it is that in water we have lots of water molecules, and they are really attracted to each other. Basically the positive bit in the water, which is the hydrogen, is attracted to another the negative bit in a neighboring water. So water molecules are generally quite attracted to each other. This is why water's got really high surface tension. If you jump off a large cliff and fall on water, it'll feel like concrete, because the water molecules are quite attracted to each other. Water also has quite a high boiling point for a molecular substance. Same reason, they're really attracted to each other. If we put the iodine in water, the iodine is non-polar. It hasn't got a polar or a negative end, so it's not going to be very attracted to the water. So basically, the water is more attracted to other water than it is to iodine, so it's not going to dissolve the iodine. So yeah, for iodine and water, the iodine-water attractions are not strong enough to overcome the attractions between individual iodine atoms, or the water to another water molecule attractions, which are quite strong. In cyclohexane, if you put iodine in cyclohexane is non-polar, so it's not that attracted to another cyclohexane. So these attractions between two cyclohexanes aren't that strong. So the iodine is attracted and can be dissolved by the cyclohexane. It's a tricky question, that one. Really good though. Let's have a look at another one. So here is one from 2 years ago. We have 4 different solids: ionic, metallic, covalent, network, and molecular. We haven't looked at the middle 2 yet, but we have to decide which one is ionic and which one is molecular. So firstly, I'll look at molecular, and I'll go, the thing I know about molecular, which I learned before, is that they have low melting and boiling points. So which one of those have the lowest melting and boiling point? B, 44 and 280. Conducts electricity? No. Okay, that's good. Soluble in water? No. Well, that's fine. Some can be, some can't be soluble in water. But yeah, if it's not soluble in water, it definitely could be molecular. So B is molecular. The other one we know is ionic. And the thing that we remember about ionic, or at least I do, is that ionic can conduct electricity when it's liquid, but it can't when it's solid. So the only one that does that is this one here. Let's have a look at a molecular question. B. Elaborate on the differences in the melting points of solid B and D with reference to the particle structure and bonding. So we'll just talk about B. B is a molecular substance, and the particles are held together by weak intermolecular forces. because these forces are quite weak, not much energy is required to break the intermolecular forces, so it has a low melting point. Yeah. So is what they say. Let's see if it's about the same. Solid B is composed of discrete covalent molecules which are held together by weak intermolecular forces. Okay. These weak intermolecular forces are easily broken, so the molecule can be separated with little energy, therefore the melting point is low. Yeah. So those are some examples of exam questions. Once again, they're super repetitive, same every year. But what I'm going to look at now is some work in this iPad. So where are we? Here, polarity. Here is an experiment that we could do at school, but maybe you can guess what happens. If you've ever got some water, you get it out of a tap and you maybe you run a pen through your hair and hold it up against it. You may see that the water deflects towards the pen. If you try that with cyclohexane, the same would not happen. So basically you're showing one is polar and one is non-polar. Water is going to be polar, deflected towards the pen, while cyclohexane is non-polar. Explain why polar liquids are deflected by static charge. In your answer, you should refer to a Lewis diagram above to the bond dipoles and to the effect of symmetry on the molecules on these bond dipoles. So if you look at these two, you can see that water is in a bent shape and the dipoles do not cancel out, while cyclohexane is very symmetrical, even though it's really big. So the dipoles do cancel out, so it's going to be non-polar. And when you rub the pen on your hair, you're charging it, you're removing electrons from it, making it positively charged, so you're attracting it, I believe. Is it positively charged? Yes. So polar molecules are attracted to electrical charge because of the molecular dipole. If the charge object has a negative charge, it will attract the positively charged water molecule, or the positive part of the water molecule, while positively charged objects will attract the negative part of the water molecule. While symmetrical molecules don't have a dipole, so it's not going to be attracted to the charged pen. That's quite a difficult experiment or question. Here's another one about dissolving stuff. We're not going to worry about that, the actual experiment. But for the explaining solubility, you can use this little recipe here. And it's basically exactly the same as the it's basically the same as the one for polarity. You just go through and you explain the polarity, and then right at the end you say polar substances dissolve in other polar substances, therefore ammonia does dissolve in water. If you can do page 66, maybe do page 67 as well, but page 68 and 69 are pretty much exactly the same, so don't worry about that. And the last page I'd like you to do is page 70, just page 70. And that's looking at the melting and boiling points of these molecular substances. So in total, what I would like you to do is from page, let's just say, sorry, give me a moment. 64, 64, 66, 67, and 70. Cool. That's a fair bit of work. And so I'll put these numbers on the comments, in the description of this video of what pages you need to do. And I will see you tomorrow around 12 or 1 o'clock. I'll send out the invitation soon. Cool. Hope you're having a good day and dealing with the lockdown. I think it's going to be over soon, fingers crossed. So awesome. You're doing really well. See everyone later.